Can you hear me?
Go sawa.
Welcome to our last Build with AI session. My name is Faith Chebet. I'm a GTG UI UX lead, and today I'm going to be your host. I want to appreciate all of you for participating in the last 5 sessions. Thank you so much, and welcome for today's session. Let me welcome Alex so that he can take us through something. Welcome, Alex.
Yeah, okay, good evening, everyone. So, yeah, I'm Alex, and as you know, the norm, we usually need to get some cloud credits because I believe this session will be hands-on and you're going to be needing them to perform some of the things that we're going to be doing. Yeah, because I'm going to assume we'll be using Vertex AI, and Vertex AI is usually paid for. And since we can't use our own money for that, Google has provided us with cloud credits. In this case, you'll have to visit the link that is shown on the screen. It's also pinned in the charts. So once you go to that link, you'll get the option to, you'll get such an interface where you'll be given cloud credits which are worth $5. Yeah, you can use them now for the lab that you're going to cover today. So the link is try GCP, and then our subURL will be build AI HKEM01. Yeah, so once you've accessed your credits, you'll be told to create a billing account. And yeah, you'll be able to use Vertex AI because I believe that's what we're going to be using today. Today we're going to be covering something to do with RAG. I believe it's all about like trying to link an LLM to a data source, because I believe, you know, ChatGPT and other AI models usually have they usually have some limited data. So let's say in this case I want to add extra data using maybe a document or a database or any other source. Yeah, I believe that's how it works. I'm not that much of an AI person, but yeah, we have a speaker today who's well versed in this field and he's going to explain to us. Yeah, so make sure you redeem your credits in case you want to follow along or use them maybe in the future. Make sure you redeem them. And yeah, for the labs, we'll also be sharing the links as we go on throughout the call. Yeah, so right now I want to welcome Moses. Moses is an AI and machine learning researcher. And Eric, naona kuna tumemaliza credits. I think you can use another email if you manage to RSVP with another email too. Yeah, or you can DM nikutumie zingine. So yeah, so I guess that's it. I want to welcome Moses to lead us in this session. So welcome, Moses.
Okay, hello. I hope I'm audible.
Yes, we can hear you.
Okay, so also I'm having some issue accessing my credit, so I think I'll just use the other account that I already have because I'm having some difficulty accessing the credits. So let me share my screen just a moment. So Alex, I don't have permissions to share my screen. Can you kindly enable? So while I share my screen, so as Alex have said, Moses Mdogo, or others know me as Sharks Rains. So I'm also a student at the University of Embu and interested in machine learning. So I do study about machine learning. So I'm doing master. So currently I'm planning to specialize on doing machine learning and deep learning. that includes the AI. So not much on the generative part, but I have some knowledge about it. Not an expert per se, but I have some basic knowledge about it. So I'll be taking you through today's session about the RAG and the multimodal using the Vertex AI. So just a moment so that I can share my screen. I hope my screen is visible from your side.
Yeah, the screen is visible.
Okay, so the first thing that we are going to do today is to go. I'm going just to pass through the one of the courses that is inside the Google Cloud Skill Bot about the multimodal, about the RAG using multimodal, using the Gemini API in the Vertex. So if you don't have a Google account that already have credit or your credit has expired, you can also use this course because I believe you're given credit also on the Google Skill Bot, about 35, I think about 35 credits. So if, on this one also you'll be given a lab to try out the RAG part. So we'll just start with the brief introduction of RAG as per the this lab. So as we know, AI sometimes, as we know, the generative AI were trained on large amount of data. So if you want to ask about specific thing, like let's say for example, you have in some notes that AI was not trained on, or let's say for example, you are trying to analyze some small businesses financial statement. So those documents were not trained on by the AI, so it will be quite difficult for the AI to give you the accurate answers. So there's where the RAG part comes in. So using the Google, the Vertex AI, the multimodal part. So as we know, the financial document, like for example, they usually contain text and some diagrams. So initially it was quite difficult to interpret the diagrams and the graphical parts because the RAG was used to only support the text part. But now using the multimodal, you can also be able to deal with audio, the images, and also the videos. So what RAG does is that you take your documents, then you create a vector database. Then from that vector database is whereby you'll search the information about your the AI will be able to get the context about your questions from the vector database and be able to give you accurate answers. And you can also cross-check to see if the answers that they are giving you is from your documents. So that's all about the RAG part. So it's majorly when you want to have an AI that is customizable, like to make the LLM to be customizable to your specific need. So you give it the information so that you can be able to answer the question based on that information. So I think I'll just take you through the lab. Then after that, we'll go to another project if you have the credits to do it. So I think if you have your time, you can go through these theories and see what they are talking about the importance, the comparison between text-based and multimodal. So the multimodal, it offers various advantages over the text. As I have said, you can be able to interpret the graphs, the images, and sort of sort. So the prerequisite for this, you need to have some basic knowledge about Python, and also you need to have some general API concept, and you need also to have some knowledge about running code on Jupyter Notebook or Colab, but they're just basic, so it's not a mandatory. So yeah, on this lab, you'll be teach on how to extract and store metadata of a document containing both text and images. Then you will embed those. Uh, you'll also embed those documents. That is the metadata that's extracted from those documents, and you can be able to now search the metadata with the text query to find the similar text or images. And then after that, now you can use those contexts that you have searched from the vector database now to get contextual answers that are based on your data. So yeah, just the information on what you need to know, and then just some basic information. So I think we'll just go into the lab and show you how it looks like. Just a moment. So the lab is on. So after you open the lab, you need to click here to go to the Google Console. And then another things, if you will be trying the lab on the cloud scale, make sure you do it on an Ignito window so that it does not conflict your Google account settings on your machine. So when you are in this window, just search here the Vertex AI. So it's here. So after that, you'll come here to the workbench. And then here to the Jupyter Lab. So here we are having an instance of Vertex AI running. So I tried to set up it to run it on my account, but I saw it was a bit too expensive to run it on the notebook workbench provided by the Google. So running it on a Colab is just okay. If you have a Colab account, I'll show you on how you can try out your various RAG. And then after that, after you have figured out the best approach that works for you, then you can convert it into your final project. So just a moment while it runs. So it's taking a bit long to run it. So if you have a Google Skillboard account, you can follow it along. So here is the course that is on the Google Skillbot. So if you want to just get your hands on and try some basic multimodal RAG, you can go through this course and see through the code. They're having some very nice explanation on what is going on. So you'll be introduced thoroughly into the multimodal RAG using the Vertex AI. So the dependencies that you need to install is the Google Gemini and this one, the PyPDF. So this one is for reading the PDF, and this one that will give us the access to the Vertex AI models. So I think I'll just go through it a bit faster, and then I'll move to the other one. So I'll just explain what is going on just a bit. So if you are setting up your project, what you'll need is the project ID and the location, even if you are setting up on your own Google account. So for this part of the course, you'll be provided by the project ID by Google and also the region. So you just need to change these values of your project ID and also the value for the region. So while it runs, since it takes a bit of time, I'll just go through it just for so I think everyone knows how to run a code on notebook or Colab. If you don't know, so you just press onto a cell that you want to run, and then you press shift and enter, and then the code to that cell will be executed. Or you can use this button here you select a cell that you want to run, and then use this button to run that cell. Also, when you select a cell, you can have this button. You can use it to run that cell. So here there is just the library that they are going to use. So under the Vertex AI, we have some generative models. So these are the classes that will be used to load those models. Then from there, we are having here some utility functions that were written for this part. So you need to run this to download it from their repository. So here's the link to their GitHub repository where they have those utility functions that will help you to do some parts, as I'm going to show. So here they're importing this, like for example, the get document metadata. So this function is implemented on their, just a moment, here on their utility class. So when you come here on their utility class, you'll get various functions that have been implemented to help you in performing various parts, like loading the images, generating the image embedding, getting the text embedding from the text model. This one loading the image, getting the PDF document object. This one getting the text. There are various utility functions that help to perform some specific tasks. So if you find that there are some method that you see that have been imported here, so they have been written here on the utility file. So I'll just go through it just a bit faster. So what this course does is that just a moment. So I'll start with here. So here they are loading the data. So you have been given here a file that has some data. So this one is a market. It's a document about stocks. It has some text and also it has some images. So as you can see, it has some text and some images. So initially it was difficult to process the document that has both text and images. We are only able to extract text and use that text to answer various questions. But right now we can use both the text and the images that are in the document. So as you can see here is where we are loading those data. Then after that, we are using this function to get document metadata. So this one enables us to get the text metadata from the PDF and also the image metadata. So it takes in the multimodal model as the parameter, the folder that contains those images, also the prompt and the embedding size. So this one is the amount of tokens, like the size of each embedding, the length of each embedding. Then here we are having some prompt. So here we are telling it to explain what is going on. We're telling it to explain what is going on in the image. If it is a table, to extract all the elements of the table. If it is a graph, to explain the findings of the graph. Do not include any numbers that are not mentioned in the image. So here is a prompt that we are giving it into the model to be able to guide it on how to extract the information. So here, this one, the multimodal is here that we have initialized here. Just a second. So here. So we are using the Gemini 2.0 Flash. So during the first models of Gemini, so the Gemini 1 and 1.5, they were different. The model for images, for videos, and for text were different, but from Gemini 2.0 and above. So Gemini 2.0 Flash can be able to process both images, videos, and text. So we're just using a single model for all that work. So here we are using Gemini to load the data. Then after we load the data, we extract various important information from it. Then here we can able to preview the information that has been extracted from the document. Say here's the file name. So we have in here two files, the part 1 and the part 2. So is the file, the text from the file, the embedding. So embedding is just converting it into vectors. And then we have in the chunk. So the document is splitted into chunks. And then we have in here the chunk text and then the embeddings of the chunks. So this is the information that the model is able to get from the PDF that you upload. So the text will take it as a text, the image, it will put it in an image part and give you a description on what is going on the image. So as you can see here, we are all able to get the image description, the embeddings of the text, the embeddings of the image only, and the image description, the embeddings of the text and image description. So here we can be able to also to get the image metadata. So it's giving us the document and the image that was extracted there. So here is the image path, and here's the image description, and here it's embedding. Then from here they are loading various helper function from the utility. So the function to be able to display an image, to be able to process a response from Gemini, to be able to query a similar image from the vector database, to be able to query a similar text, to be able to print a text to image citation, and to be able to print text to text citation. So if you want to see how those methods have been implemented, you can view it on this file. From here, you can see how those various functions have been implemented. So after that, here they have in a query, I need a detailed for basic and diluted net income per share of class A, B, and C of shares for Google. So here is the text search. So here it will only be able to search to get similar text from the query. So it will go through the text that were extracted from this document and be able to return the text that are related to the query. So yeah, and it returns the confidence. So this is the confidence score. So it's 76% confident that our query relates to this one. And as you can go through the text chunk, you can see here the share amount per class C, B, stock year. So you can see the text is relevant to our query. Also here we have in another text chunk, you can see it also have some information that is related to our query. Also this one. So it will return all the documents that are relevant to our query. So you can be able to filter out which information will you pass to the will it pass you now to the LLM to be able to answer your questions. So it's only returning top 3 documents. So you can put it to return only top 1, or you can put it to return all the documents, then you select the one with the highest confidence. So after that, here we are having another prompt. So here we are creating a context. So we are looping through this information, and then we are creating one as a single context, so that we can pass it into the LLM plus our query. So this one is a simple prompt. So we are telling it to answer the question with a given context. If the information is not available in the context, just return not available in the context. Then we're giving it the question and now our context. So here we are instructing the LLM to be able to answer only if the context is provided for that query. If it does not find that context, now it will not be able to answer. So here we are passing the text model. So the text model, because we are only passing the text into the LLM, then we are passing it the temperature to be 0.2. As I remembered, I think it was Eric who was teaching about the LLMs and the basics of RAG and the meaning of temperature. If I'm not mistaken, temperature is it. We set it to make sure the LLM, whether we want it to be creative or not. So if you put it as 0, it will answer the question without adding any creativity into it. And if you put it the maximum of 1, so the LLM will try to be creative. So while using RAG, you need to put it as low as possible so that it sticks to the context that we have provided. So as we can see here, we are passing the query, which is similar to this one that we have passed into the RAG. I need a detail for the basic diluted per share. So it will be able to get this context, then this context we merge it, and then we pass it to the LLM together with our query, and we can see the results. It's related to the documents that we have given the LLM. If you try to ask the LLM without the context, let's say for example, let us modify it here. And set our context to empty. So as you can see, the result is that it's not available in the context. So it will tell us that the information is not available in the context. So the Gemini will not start hallucinating and give us some rubbish answers that are not related to our question. But when we return the context, now it will be able to give us the answers based on the context. So this one is very important when you are dealing with some niche problem that you need the LLM to give you the answer based on your specific documents. So after that, we have in here, the first part was for the part of the image. Then the text, sorry. Then the next part is the part of the image. So yeah, it is the same query, but now here we are going to use the image. So here we are getting similar image from the query. So we're getting the top 3 images that are related to our query. So as you can see, it's returning the images as the response. So this was the function to print the image. So it's returning the image as the response. So we have which is relevant to our question. So having a class A, class B, and class C share of Google. Then from there, we are now going to use this image now to answer our question. So here we're going to get the response from the Gemini. So we have in similar here. So you are passing the context. Now our context contains the image and the description of the image. And then we are passing here our query. Then you're telling it to answer a question in a JSON format with the given context of the image and its description. Only include the values. So we are requesting it to only include the value from the image. So let's see how it performs. So as you can see on the results, it's only returning the values. So it's returning the classes that we have passed through the query, and it's only returning the net per income of the shares from the table. And as we can confirm, the values are the same as the one that are here on the image. So this one is just to print to get the top documents as we did on the first one, and the description of those documents. So also we can do an image search. We can query the vector database to get some images. So like we can use an image as a query. So here, as we can see, we are loading an image. So we have in this image, so it is printed here. Then here we are getting similar image for the query. So we are going to pass the image as the query to the LLM and see if it will return an image that is similar to that. So as you can see, it has returned an image that is similar to that based on the data that was embedded into it. Then this one is for getting the citations, the image citation. So it's like the description of those images. Then yes, it's just printing the part where that it extracted that image. Then here we have in the comparative reasoning part of it, whereby we provide a query, and then we provide it to compare different images and then return a results based on that. So as you can see here, we are having some graph. We are having some graph that has some line plots. So as you can know, the line plots are used to compare different variables. So as you can see here, the red line represents the alphabet. We have in the green one representing the SP500. Then we have the NASCAR and the different companies. Then from that, we are giving it a prompt. So the instruction is to compare the images and Gemini extract text provided as context to answer the question. So make sure to think thoroughly before answering the question and put the right step to arrive at an answer in bullet points for every explainability. So here we are giving it the context. So the context we have in image 1 and image 2, and also the descriptions of those images. Then we are giving it the question. So the key finding for class A share, what is the critical difference between the graphs? What is the key findings of? So we can give it a detailed question. Just a moment. So it's taking a moment to return the answer. So as you can see, so it has returned a detailed answer based on the question that we have given. So understanding the context of image 1, so the graph comparison, so it tells us what image 1 was all about. So here was our image 1. And also the image 2 is a table summarizing the alphabet. So it's also giving us the details about the image 2. and then answering the question about these questions. So about the difference between class A shares concerning the SP500 and the rest. So as you can see, it's giving detailed answer based on the images that we have uploaded. Then here you can give a user query. So you can create a detailed query. So here was the sample query. What is the critical difference between the graph in A? So it's almost similar to the one that is here, but a bit different. So after that, we get all the relevant text chunks from the vector DB. So this is the helper function to be able to do that. Then after that, we are getting all the relevant images also based on our query. Then after that, we are creating a context of text and images. So here we are linking we are creating a detailed context that contains both the text and images. Then after that, that context is being passed to Gemini with the prompt of instruction, compare the images and the text provided as the context to answer the multiple questions. So make sure you think thoroughly before answering the question, put the necessary step to arrive to an answer in bullet points for easy explainability. If unsure a response, not enough context to answer. So here we're giving it the context of the image, the context of the text, and our query. So it's taking a bit to process. So as you can see, it has given the answers and also the step on how it reached to those answers. So what is the critical difference between various graph of class A shares? So as you can see, it has given the graph compare, multiple comparative. So it's given the details about those graphs and also how it reached through those answers. So as you can cross check the answers that it has been given here to your documents, and you can see that those information were available in the document. So here is just to print the citation reference, also to print the images that were used to query the LLM. And here's the text that was used. And then lastly is the chunk. So you print the chunks of the citations that were used without the description of the images. So you can go through this and look on how each part was implemented in details. Also those helper functions, you can find them here, and you see the specific implementation of various things like how are we able to query an image, are we able to process an image using various techniques, how are we able to process text, and how are we able to break the text into chunks. So you can able to do this even if you don't have a Google account with Billion through the Google skill board. And then after you complete the course, you can come here and then you check your progress. Then after it finishes, so it will tell you have completed the course 100%. So if you stop the lab now, the workbench will stop. And if you have created the workbench using your personal account, if you finish running your workbench, make sure that you disable it. After you finish running your execution, make sure you disable the instance, since it's quite a bit expensive. So that was the first part. So if you have any questions, you can ask. So kila mtu ako sawa? Anyone with any question?
Hello, Moses, are you still on the call? Umeenda silent kidogo. Just
Just a moment. I
okay.
add my environment variables to the column.
So.
So is my collab screen visible?
It's visible.
Okay, so here it's almost the similar steps, but now we have all the functionality on one place. So if you have a Google account that you have some credits, so after you have created the instance, so I'll share the code. So what you need also to get is the project ID and the location. To make sure that you run the call on the same account that you have the credits, because you're under the authentication, the pop-up will be required to log in with your Google account that you have the credits. So let me start. So RAG, as I've already said, it's a technique that we used with LLM, so the large language models, to be able to get relevant information or the knowledge about the source. So, like for example, if you, let's say, for example, we had an idea to create a study buddy. So you create an LLM application that you can be able to upload your notes, various YouTube videos, and some images. And when you revise your past papers, so if you ask your questions, it will be able to answer you only based on those questions. Or while you are revising, it will only be able to answer you based on those questions. So it's a simple workflow of the RAG. So how it works is like you have a PDF. So as you can know, the LLMs have a limit of the context window, the amount of knowledge that they can take in at a given point. So if you have a PDF of like 1,000 pages, so the chunking part is to break that document into smaller parts. So if it's 100 pages into 10 pages each, then after that, after you split that document, so each chunk, it will be a piece of its own text, but it has a link to the previous chunk and to the next chunk. Then after that, you generate some embeddings, which is like converting those texts into vectors. Then after that, you save it into a vector database of your choice. So each chunk, it will be stored into the vector database as its own specific text. Then after that, after you have in your PDF, you have broken it, and then you have saved it into the vector database. Now you can be able to use that vector database to give the LLM the context. So here we have in the vector database. Then after that, we have in the chunks. So we can be able to now to retrieve the chunks that are relevant to our query from the database. Then we use these chunks to pass it into the LLM, and then after that, we are now able to get the answers that are only relevant and are present into the documents that we given it into the LLMs. So someone might ask, so instead of going through all that hassle, why don't we just upload the documents into the, like, say, of ChatGPT or Gemini and just get the answers like that? So that one is possible, but as we know, the data that we upload on the LLM are being used to retrain the model. So if you upload there some confidential data about some businesses, so it might leak, because I think we had some instances about Samsung. So some Samsung employees uploaded some confidential data to ChatGPT, and that data was used to retrain the model on the next page. So if the public goes to ask the information about your confidential data, so it will be able to get some answers because the LLM has the knowledge about it. It was retrained using that data. So using the RAG path, it's good for privacy and also to give your confidential data private. So that data will not be used to retrain your model because your entire context is not fed into the LLM, only in the relevant part. Also, another thing is that the input window. So as you know, the LLM are a bit expensive if you are using the API key. So you are paying in terms of the input tokens and output tokens. So if you fed in your 1,000,000 documents into it, so we are going to pay quite a bit. But if you use the RAG approach, so you'll be only sending a small chunk of the documents into LLM, which will be a bit cheaper and faster. Also, the LLM, after some point, it kind of forget what we had given it. So using this approach will enable it to remember and to reduce the acceleration from it. So here is the gains of the RAG has gained popularity due to increase of accuracy and relevance. So RAG allows the LLM to provide more accurate and relevant responses, as we have said. Also, it enables the LLM to reduce the hallucination, as we have also said. Also, it's greater for adaptability, so can be able to adapt the LLM into a specific need. Also, it enhances the user experience. So the RAG can improve the overall user experience by making it reliable and relevant responses. so will not be given some vague answers by the LLM. Then why multimodal? So in today's data, like for example, the PDF. So like for example, the PDFs. So the PDF has both the text and some images. So processing it using the text model is a bit hard at the moment. So using the multimodal will enable you to get the insight on the text and also the images that are present on the documents, as we have already said. So here it's also some explanations about it. So we use the multimodal to do the embedding. So we embed the text and the images. Then after that, we retrieve using the similarity search. Then after that, we pass both the relevant raw images and text chunk to the multimodal LLM to answer the questions. And then after that, we use the multimodal to generate the text summary of the images. Alafu after that we embed those and retrieve the text. Then we pass the text chunk into the LLM now to answer our question. So how it works is that at first we pass the document into the LLM, the multimodal LLM. So it will be able to extract the text and also the images. Then those images, we pass them also to the multimodal LLM to be able to give us a brief summary of those images. Then those texts will be embedded and saved into the vector database together with the metadata, with a link to exactly where the image is stored on a normal database. Now, when you query and to get some specific text that are relevant to your text, now the LLM the multimodal retriever will be able to get the image from the database together with the text and then pass it into the multimodal LLM. And then we'll be able to get the answers that are relevant to that. So you can read more on that from the LangChain blog. So I've linked it here. So yeah, it's also some what we are going to build. So it's just a data loading using the LangChain. So for the other one, it was purely vanilla Python and the libraries from Vertex AI. So here we are integrating the libraries from Vertex AI with LangChain. So LangChain is one of the frameworks, or let's say a combination of libraries that is used to do the RAG part. So we have in LangChain and also the Llama index. So if you are familiarized with any of the two, so you can either use the LangChain or Llama index. Either of the two will work. So we are using the LangChain to do the data loading. Also, it has some inbuilt function for retrieving and others. So after that, we generate the text and summarize using the Google Gemini Pro model. Then we generate the images and we summarize them. Then after that, we create a multi-vector retriever using the Google's text embedding model with ChromaDB. So ChromaDB is an example of a vector store. Then after that, we develop a multimodal RAG chain for question answering. So before you begin here is where you need the Google console and the billing to be enabled on your project. So if you have in the credits, you can enable the billing, and then after that you can under the Vertex AI SDK, and also you need the LangChain for the implementation. So on I think I'll share my screen on the other part. Just a moment. So after you have your billing enabled, so you'll select the projects that you want. Then after that, you will go to, just a moment. Let me see if I have an account with billing enabled. So after that, we'll come here into the Vertex AI dashboard. Then you'll enable all recommended API for the Vertex AI. So you'll just click enable all the recommended API after you have enabled the billing. And then now you can use that account. So the region, you will get it from here. And then the project ID you'll get here from the project. So you'll get here the project ID. Then after you have that information and you have enabled all the recommended APIs, now you can proceed with the other part. So this was just the theory part. So I'll share the link to this collab if someone interested with the theories of it. So here, apart from the Gemini library, so we also need in the Langchain and the ChromaDB, and also some other Python library for some pre-processing, like the pillow for the image, this one for PDF, this one's for concurrent processing, and the other ones. They're just some other Python libraries that are required for some pre-processing. So here you'll come and set your project, the project ID and the project region. So it's not advisable to upload your confidential details on the collab, because you're going to share it with other people. So you'll create a .env, and then on the .env you'll set the project ID to your project ID, and then the location to your location. Then after that, you'll enable this. You'll authenticate using this one. So a pop-up will come up, and then you log in into the Google account that you have authenticated using that one. Then after that, so here we are using the Vertex AI. So we'll initialize the project by our project ID and also our region. Then here we are preparing and loading the data. So you're going to use this data, the Langchain documentation data, for benchmarking. So let me download the data. So here we have in that data. So it's some images. And a PDF that contain also those images and some text. So this one is one that we are going to use here. So after that, we are going to use the PyPDF loader from the Langchain to load our PDF. So after we load our PDF, you can be able to see some sample text that have been loaded from our PDF. So the first text, as you can see, have been provided it here. So this one is a simplified version to load your PDF that has been implemented on Langchain. Then after here we can be able to get the total length of the text that were loaded. So we have a total of 21 texts. Then here are other libraries that we are going to use to generate the text summary. So here from Langchain, we have in the Vertex AI, we have in the chat Vertex AI and the Vertex AI embedded. Then we have in a prompt template to create the prompts, as we saw earlier. This one for the message, then this one for using the piping approach of the Langchain. Then this one is for passing the output into a readable format. So previously as I had said, so just a moment. So initially we had a Gemini Pro that was used for vision and images. So if you get some code that has Gemini Pro, so right now they're using the Gemini 2.5 or 2.0 Flash and Pro to do all the processing. So you don't need to have a different model for vision and other stuffs. So here we are having a function to generate the text. So we pass in here the text, the tables, and then we enable either the summary of the text to be true or false. Then you're going to get the summary from the tables. So our prompt is, you are an assistant tasked to summarize in the table and the text for retrieval. So this summary will be embedded and used for retrieve the raw text or table element. So give a concise summary of the table text that is well optimized for retrieval, table or text, and then here is the element that we are going to pass. So we're going to use the prompt template from LangChain now to create the prompt using this prompt. And then here is the AI message. So it's converting it into a message that is understandable by the LLM. Then you are putting the temperature to 0 so that it gives strictly based on the instruction. The answer is strictly based on the instructions that we have given it. Then here it will use you'll use the Vertex AI model. Then here the model name is the Gemini 2.5 Flash. So after that, we are going to call this method summarize chunk to summarize various texts that we are having and the maximum number of concurrency. As I said, we have a library for pre-processing it concurrently if you have a computer with multiple processors. So here we are going to pass our text, the table, and then we are going to get the summary. So that text is the one that we have generated from here. And then here we also we also loaded the tables. But for now they are empty from the document. So we are going to pass the text and the tables, and then after that we are going to get a summary of them. So it will just take a moment. Then after that, we are going to use the LangChain human message. And here we are going to generate image summaries. So the LangChain human message is a library that enables us, or a class that enables the LLM to return a message that is easily understandable by the human instead of its format. So under the image summarizer, so here we are using the Vertex AI. So the model vision, we are also using the Gemini 2.5 Flash. And then after that, we are going to pass our prompt, and then we are passing the image data after it has been encoded into base 64. Then after that, now the LLM will be able to return a summary of that image. So here we are passing the prompt. So you are an assistant tasked to summarizing the image. It's similar to the text one, but here now the input is the images. So it's going to take a minute. Then after now we have retrieved our text from the document with the help of LangChain and get the summary of those texts by using the Gemini. So we are going now to create the vector store. So you are going to build a multi-vector retriever. So from LangChain, we are going to use the multi-vector retriever to help us to do that. So in memory store, it's just used to store the data to your RAM or your memory. Then the ChromaDB is the vector store that we are going to use. Then this document is to convert the raw text into a document format that is used to store data in vector database. So after that, we are going to create the vector retriever. So the vector retriever is taking the vector store, which we are going to initialize it here. And then after that is going to text the text summary that we have created using the Gemini. And then the text, the full text, then the table summary and the table, the image summary, and those images. So here we have in a function to add those document summary and their document context. So the way it works, if you have ever worked with the text, with the rag using the text only. So under the rag using the text and both the images, so we are doing quite a similar thing. The only thing that we are doing is that we are now going to store those raw content of the images and the text into now a doc store, which is like another database that is going to store now the raw text. So only the summaries are going to be added into the vector store. So the images and the full text are not stored into the vector store. Only the summaries will be stored onto the vector store, and the two of them will be able to get the full context from the doc store using this doc ID that we are generating it here. So they will be unique to each chunk of the document that is being stored, and it will be stored on the vector store as the metadata. So by using the metadata of the document, so we'll be able to also to get its full context from the doc store. So after that, here we are going to embed the text, the tables, and the images. So here is a vector store. So the vector store is a chroma DB. So you are going to give it the collection name. Then this one is a Google Vertex AI model that is used for embedding the text. So it's used to convert the text into vectors for faster and easier retrieval. So after that, now we are going to build the multimodal RAG. So here we have in some helper functions. This is a function to plot the base 64 image. So we can be able to view the image. This one is a function to compare or to get the lookalikes of the base 64. Then here is a function to check if the data is an image data. Then here we have in a function to resize an image. And then here we have in a function to split the image text type. These are just helper functions. Then after that, we are going now to define the domain of the specific image prompt. So here, the text is that you are a financial analyst tasking with providing investment advice. So you'll be given a mix of text, tables, and images, usually for charts or graphs. So use this information to provide investment advice related to the user questions. So here the user will provide the questions, and here's the formatted text. So this one is a prompt that we will be giving our model together with the context, so that it will be able to reply from those context. Then you are going to define the multimodal RAG chain. So this one is a chain that will be used to do the task. So here we are initializing the model. So it's the vision model, so which is still the Gemini 2.5 Pro. So here we are going to initialize the chain. So under the chain, we are going to give it the context. So the retriever will retrieve the context and use this helper function to split the images and the text. Let's say, like for example, we are having both images and text together. So what it will be able to do, it will be able to create a list of objects which will have in the image as image, and then the link to that image. And if you have in a text, so it will have here as text, and then the context to that text, to make it easier for the LLM. Then after that, this will also pass that question that we use to retrieve the information into the LLM, and then the LLM will be able to return the context and pass it into string. So this one is our multimodal RAG chain. that will be invoking the query. Then the query will retrieve the information from the vector store. Then after that, that information will be passed into the LLM together with the context and enable us to get the answer based on the context. So here I was just looking at the list. So here is our query. So we are an EMT growth MongoDB and Flyer data and Cloudflare and Datadog. So we need it to get the EV and NTM and NTM revenue growth of MongoDB, Cloudflare, and Datadog. So here we are going to use the multimodal, and then we are going to get the relevant document. So here is just retrieving the relevant document from the RAG, just directly without passing it into the LLM. So it's going to take a minute. So yeah, it has retrieved both the image that are related to that, together with the text that is relating to this question. Then here you can be able to view the images. You can see the image is the first element of the list, so you can be able to preview the image. Then after that, you can also be able to get the image summary of the first image. This is just for comparison. Then here now is where we are using the RAG chain, the multimodal RAG chain. So we are going to invoke the query, which is this one. So what it's going to do is going to extract the context like this one, and then pass in this context together with the query into the LLM, and to be able to return the answer based on that relevant data that we have given it. So also we have also some downside of the RAG. So let's say, for example, you pass a query that is vague. So the LLM can be able also, the RAG can be also not be able to retrieve the relevant information that is specific to your need. So if you're using your Google account to do this test, so after you finish, you can go to your Google account console, then to the manage resources page, and make sure that you disable or you shut down your project, because it will continue to take your credit even if you are not using it, as long as it's running. So that was it from my part. If you have any questions, so you can ask. So my part was just to introduce the basics. So after that, maybe I'll share a GitHub repo. So using that information, maybe we can do a challenge of now creating a real world application after you have learned the basics about the RAG, the multimodal RAG, to do the images and the text. So we had an idea earlier, a bit ago, before the LLMs came, to create an application whereby we can be able, let's say, for example, you're learning about, let's say, calculus or some other stuff. So in that application, you can be able to upload the notes, the PDF. Also, if you're having some Google videos, you can go to YouTube to download some videos, then you upload it there. And also the pictures that you usually took on the blackboard that we never read. So you upload it into the application. Then after that, you create it in a way that those information will be pre-processed using the multimodal of the Gemini multimodal. Then after that, the summaries will be saved, embedded. Then when you later come, let's say 30 seconds or minutes to exam to revise, if you ask the question, it will be able to answer based on those notes, the YouTube tutorials and images, without going to scroll to specific pages that you have in the doubts about it. So I'll create a GitHub repo and then I'll share the link. Then the people who are interested can contribute onto it. So I'll just create a boilerplate of the project and then share it. The people who are not interested in AI too much, so they can help us to build either the mobile application or to build the interface with either Angular or React or both. So that's it from my part. If you have any queries, you can ask.
Okay, that was a very great session. Thanks once again, Moses. Yeah, mi nimezoea kuita Sharks. Yeah, it was an awesome session, and it's our last session in the Build with AI series. I mean, we've done a lot. We've done a lot. Vitu mingi sana, and yeah, so we'll be finalizing with that. Yeah, but there's still some stuff that needs to be done. Yeah, first of all, there's some challenges that you're supposed to do, like build inaitwaje. You can build a project with Firebase Studio, publish it, and what else? Just sharing whatever you've learned throughout the whole Build with AI series. Also, there are various courses by Google. Let me share the document. Just a minute. Yeah, we also have some courses by Google. So Google has offered us 4 courses which you can take. Actually, it's certification courses. We have the Cloud Digital Leader, Generative AI Leader, Cloud Engineering, and Cloud Data Analytics learning paths. So once you've done this, you're eligible for a 50% discount on the exam voucher. Yeah, so assuming maybe you are interested in generative AI, you can come and take the generative AI leader certification. There's a path for this specific course. It contains 5 courses, or I don't know how you call them, badges, paths. And once you've done them, make sure your profile is public, and you should also be part of the Google Career Launchpad cohort. In this case, that's why I'm asking you to like fill that form once you create a Cloud Skill Boost. Once you've created a Cloud Skill Boost account, you should fill that form so that I can add your email to our Career Launchpad cohort so that you'll be eligible for the 50% discount. So I'm assuming you want to take the Associate Data Practitioner certification. The exam fee is $125. That's around, let's say, 10K. But if you follow this step, you'll be able to do it at 50.
And then guys, I am unable to see the screen at the moment. So if you have any question, just unmute and go ahead and ask the question, because I can't see. So don't raise your hand, just ask the question.
Okay, Martin, maybe you can mute yourself.
I don't know why my chat.
Yeah, so as I was saying, if you are to do maybe the associate data practitioner, the exam fee plus the certification is $125. But under this career launchpad cohort, you'll be able to get a 50% discount, and you'll be able to learn, have a free lab to do all that. And once you've done it, there's a form that you're supposed to fill. The form is just somewhere here. Yeah, there's a form that you're supposed to fill here. Once you've filled it, you should be able to get a response from Google, and they'll give you a voucher which you'll be able to apply. And then, yeah, you'll take the exam and get a certification. And also remember that there's a difference between a certificate and a certification. So a certification shows that you're a master in that field. So don't miss this chance. Take this opportunity, ufanye hizo courses and everything. Yeah, because it's a once in a lifetime opportunity. I think this thing will end on 31st July. Yeah, so I guess that's it from my end. Yeah, so have a good night, everyone. Let's keep in touch pale kwa WhatsApp group. And for those maybe who are doing the cloud engineer certification, natafuta watu wa kusoma now, I'm doing that too. So in case you're interested, pia unaweza nini kwa group, and then you can get like sort of accountability partners to work with these courses. Yeah, so that's it from me. Okay, considering it's our last day, hata leo si tusalimiane. Yeah, let's nini say hi to each other. So maybe tunaweza anza na Eric. You can just say hi, tell us what you do, and yeah, and then you pass over to the next person.
Hello guys, nimeenjoy the whole session, na also nimepata kitu ingine ya kunipea headache. Fabe studio bado kiniacha tu. Thank you for joining hadi kutoka mwanzo hadi mwisho. Yeah, na tuendelee ku keep in touch. The next person maybe Martin.
Okay, since Martin is unresponsive, we can jump over to Faith. Okay, Jacqueline. Okay, anyone who is free to talk, you can just unmute and say hi. Yeah, so thank you all for joining and for participating in the series. Swags zikikuja will distribute them. Yeah, so thank you all for being part of this. Asanteni sana. Good night.